Hi everybody. I am attempting to make this video like for the millionth time because my computer wasn't working, so bear with me while I take the last 10 minutes before our next class starts and try to make this. The idea of today is to look at some visuals of infinite series. So a series is, instead of just writing a list of those things that we talked about yesterday in class, it's when we add all those terms up. So we're looking to see eventually whether, if we add an infinite number of things together, whether we get a finite number or an infinite number, so that converge or diverge. And although it might seem difficult to think that when we add an infinite number of things together we would get a finite term, I like to think about what Miles said to me earlier this year. He said, Mom, if I cut a pizza into an infinite number of slices, but I put them all back together, it's still one whole pizza. And that's sort of the idea with this here. So these are supposed to be showing us, and I'm gonna, on this first one, I think gonna try to draw a little bit. I'll have to do it with my mouse, so it makes it a little bit crazy, but they're trying to show us, so this one is 1/2 plus 1/4 plus 1/16 equals 1, and we have to really be thinking about limits. That's why this pops up in calculus instead of some other place. So this one I think helps if I kind of draw it. Again, my crude sketch. If I take half of this square and I shade that in, should probably get a bigger marker here. I think I can make it bigger. There we go. Yeah. Okay. Shade that in, and then I do half of that leftover half, and I shade that in. And I continue to do that over and over again. The idea of limits here, I'm going to draw a few things in here. The idea of limits is we are heading toward shading in the entire square. And so that's why we kind of think about this. Yeah, it really is going to add up to one whole square, kind of the eventually, or that's what we're approaching here, if that makes sense, okay? All right, and then there's another one. So this one I'm not going to draw, I'm just going to kind of point out. We're trying to add a 4th and a 16th and a 64th and so on and show that that's 1/3. So what we can see here hopefully with this square is that we've cut it into 4ths and shaded a 4th and took one of the leftovers and cut that into 4s and shaded a 4th and so on. It might be harder to see that it equals a 1/3, but I like to think of this is like a gray path right here and a gray path on the outside, and then there's one right down the middle. That's the shaded one, and that shaded one is one out of the 3 total paths. So that's one of the ways to visualize that that equals a 1/3. Here's a different shape, so same idea, cut into 4 triangles, shaded a 4th, and then one of the leftovers, so on. And so that's trying to show us, again, I kind of think of these as different paths. So there's 2 white pathways and a gray one, and the gray one is 1/3 of those paths. So here is your challenge. Your challenge is to try to use pictures, and you can use really any shape you want to try to make a visual proof for why 1/3 plus 1/9 plus 1/27, why that would equal, or again, we're thinking limiting here, approaching, would be approaching a half. I think there's really 2 challenges with this, and that is visually being able to convince somebody that you are actually cutting into 1/3 and 1/9 and 1/27. So we want to be really precise about that and make it really obvious. I don't know if that's the best word, but try to make it as obvious as possible that you're cutting into thirds. And then the other part is the right-hand side of this equal sign, which is that it actually visually looks like half of that thing is shaded. So again, going back, looking here, like I am convinced that they're shading 1/4 every time, and I can mostly visually see that we have a 1/3 of this thing shaded in. I will have some markers and some rulers and some plain white paper and graph paper so that you can kind of make some rough sketches, and then I would really like you to turn in your final visual tomorrow so that we can look at those and just kind of see what kind of creative things people came up with to show that this thing does equal a half. If you would like to get on a computer, just because you know you can be more precise with that, feel free to get that out as well.